All right, folks. Thanks so much for joining this session. We're very excited to have Mike Coleman from Docker join us at WeCloudData for this very special Docker webinar on local AI development with Docker. I'm just going to spend 2 minutes or less to tee this up and give a very quick intro and context to WeCloudData. But this webinar, as Mike will go through in a bit, is very timely considering how much people want to develop with AI and container technologies like Docker. But so who are we? WeCloudData. We're a leading data and AI training academy headquartered in Toronto, but we have clients and our business is global. In the past 8 years or so, we've developed very strong relationships with more than 40 enterprise and corporate clients across North America and abroad. We've trained at least more than 8,000, I'd say close to 10,000 students across the past 8 years, and they've gone on to be part of very, very strong enterprise development teams in data and AI, and especially in the Toronto area, we have some of the folks who've actually graduated from our programs go on to be VPs or managers of very big enterprises and companies in the Toronto area, including the top 5 banks in Canada as well. And like I mentioned, it's a global training institution. So we have business and clients across North America and globally abroad as well, including US, China, UAE, Saudi, and Singapore, just to name a few. In terms of our training at WeCloudData, it's really focused on outcomes, but to get there, we really have some key pillars, including content developed internally, a platform to host the content, including self-paced e-learning content, tailored use cases, and the delivery, many of which include instructor-led live courses, as well as personalized learning support. And we're quite proud of the capstone projects that have been built internally over the years, which have gotten a lot of success with folks going on to showcase their projects to land jobs in industry. Okay. In terms of the training process, especially with enterprise B2B training sessions that we have, it's really understanding the business requirements of those enterprises to build out a project plan, gathering the data, especially if these workshops and training sessions for enterprises, if they want to use their own data to implement and learn these solutions in data and AI technologies. We then help implement those projects for the enterprise clients and then deliver, of course, whether it's capstone project presentations or showing executive sponsors the training and the outcomes that these students undergo throughout the training process. The other unique element about WeCloudData as a training academy in data and AI is we really focus on multiple layers and unique personas in students. So it's not just one size fits all, but it's really understanding who the key audience is for each of the workshops or learning initiatives. So whether it's business leaders, end users, or builders themselves, which can include developers and engineers as an example. And within these programs and initiatives, there's different learning tracks, again, to provide the tailored learning programs for the different use cases, whether it's AI, infrastructure, or data and insights as examples. And again, we'll have a lot of these slides available for the folks, and you can also check out the website, WeCloudData.com, to see some of these in more detail, but there's business and technical tracks as well. And these are just some of the clients that we've trained over the years, especially, if you're in Canada or Toronto area, some of these will be quite familiar to you. But these are some enterprises that we've had the opportunity to work with and train in terms of data and AI. All right, so that's it for WeCloud and giving a quick intro and context to WeCloud. In the remaining time, I'm going to hand it over to Mike. Mike is a staff solutions architect at Docker. And in today's session, he's going to go over using Docker for local AI development. AI has been taking a lot of space and time in the news cycle in the past couple of years. But with that, of course, to really deploy solutions that are relevant and timely for enterprises, you also have to make sure your developers have the proper and correct development environment to do so. And MLOps, especially with containers like Docker technology, help expedite that process. And shipping, quickly with high velocity can provide a very high competitive advantage. So Mike is no stranger to the tech and IT world. He's, his resume reads like a who's who in the tech world. He's been part of Sysdig, Google, AWS, VMware, Microsoft, to name a few. So with that, thanks, Mike, for joining WeCloudData and presenting a very timely and going to be very, very exciting talk and workshop on Docker. So with that, Mike, I'll hand it over to you.
All right. Hey, thanks a lot. Really appreciate that. Yeah. So I've been at Docker now for about 15 months. I actually worked here for about 3 years back in 2015 to 2018. And so, I came back to do some more work here after some time at Google and AWS and Sysdig. Before that, VMware and Microsoft, like was mentioned. What we're going to talk about today is partly about Docker, right? We're going to obviously talk about some of Docker's technologies, but really this talk is aimed at how do you get started in local AI development, right? If you don't want to spend money on a cloud service provider, up front, you want to build something, a project, or if you want to prototype something before you release it and use it with a cloud provider, that's what we're going to basically talk about today. And we're going to talk about that through the context of developing a retrieval augmented generation application. That's going to be our demo app today. So first thing, people are like, Docker desktop, why are you here talking about, AI? You're just containers. Well, one, we're not just containers. We do a lot of container. Obviously, we were sort of the company that brought containers to the forefront. We didn't invent them, but we made them very usable. But since then, we have invested in tools like Build Cloud and Test Cloud to be able to do faster builds in the cloud, to be able to do integration tests in the cloud, along with security tools like Scout and hardened images. But really, like what we're here to talk about today is our AI stuff, right? Predominantly, we're going to talk about Model Runner, but I'll also touch on some of this other stuff. So someone said, can I build along with you? Do we need any files? I'm not really building anything. It's already built, but in the chat, let me do this really fast. HTTPS github.com Mike G Coleman / what's it called? Rag demo. I think that'll work. Try that. That's the code base I'll be using. So, and I do have that in the slides. It's at the end of the slides too, if you want to look at it later. So let's jump into it. Let's talk a little bit about Docker Model Runner. So Docker Model Runner is a way for you to run LLMs on your local machine. If you've heard of Ollama, it's a lot like Ollama. It basically uses Llama CPP, which is a industry standard for how do I serve up an LLM, right? So how do I serve this up? And then it uses an OpenAI API compliant endpoint. Now, I want to clear this up because there was some confusion when I talked about this yesterday with another group. This does not mean you need an OpenAI API key. It just means we're using that same format for the API, which means if you write something using Docker Model Runner and the OpenAI API, you can switch very easily from a local LLM to one on OpenAI. You don't have to. You don't have to pay for anything, but if you want to, you can. And matter of fact, I was doing some testing on a personal project where I benchmarked GPT-4 against a bunch of local models, and I looked at the cost and I looked at the time, and I ultimately chose to run it local just because the OpenAI, it just wasn't sophisticated enough to need a GPT-4 or a GPT-5, right? But if I needed to grow into that, I could, because that that OpenAI API is standard, right? And that means you can write it and use it pointing to Docker Model Runner, or you can point it up to OpenAI's servers as well. Docker Model Runner runs on either an Apple Silicon MacBook, so the M series, or it runs on a Windows machine using WSL2 with NVIDIA drivers and hardware. So I have both. I'm presenting to you on a MacBook. The NVIDIA machine is my personal machine. It's over here under the desk. But I do the AI on both of them, and they both work really well. So one of the things that makes it really interesting is that we are now taking these AI models and we're putting them in Docker Hub. So you can go ahead and grab a model. Let's say you don't have, there's a model that you don't have on Docker Hub right now, right? We don't have it. We don't offer it for you. You can go up to Hugging Face or wherever, grab a model, make sure it is in GGUF format, and you can package that up using Docker Model Runner and push that to Docker Hub, and you can use it in the future. I am not sure where we stand on Linux support. It should, but I don't know if we've released that or not yet. It definitely will be released if it hasn't. Yeah. But on Linux, I think you're going to need to have an NVIDIA GPU. All right, so Docker Model Runner and Docker Desktop. Let me just show it to you real fast in sort of an interactive way, right? So if I come down here, this is Docker Desktop, right? And this is the demo we'll be running later. But these, if I come right here, these are the models. And so I have all these models. I pulled them down from Docker Hub, right? So if you look at something like Llama 3.3, you can see that we offer up a bunch of different quantizations. So 2-bit, 4-bit. I think that some of them are 16-bit. We'll tell you like how big they're going to be, how many parameters they are. I mentioned before that they are GGUF format. So any of those you can kind of go in and you can find a model that makes the most sense for you, right? Do I want quencoder? So these are actually too big for my hardware, right? I only have 12 gigabytes of VRAM. And so that's the limiting factor with this. If you want to have any sort of performance is how much RAM do you have in your system? I have 18 gigabytes of RAM on my MacBook. And with the MacBook, the RAM is shared between the CPU and the GPU. So I can pull bigger models on my MacBook, but my GPU in my Windows PC is more powerful. So anyway, so I have those in there. I can come over to one of them and we'll just do, I think we're using Llama 3.2 for our demo today. So I'm just be like, hello, how are you feeling? And it'll tell me it has no feelings because it's an LLM and it doesn't, right? Because, okay, well, I am sorry to hear that. I don't know, whatever you wanted to ask it. We can go in and we can look and then at the requests that get sent. So you can go and see how many tokens were used. You can see the request format in the JSON object. You can get the response format JSON object. You can see all of that. We have abilities to inspect the models, get more details on them. And there's a direct link onto Hub. So that's Docker Model Runner. Docker Model Runner, and it is the same on, it's just on Docker Desktop. You do have to enable it. It's a beta feature. You have to come into settings, beta features, and turn that on, right? It's right here, Docker Model Runner. So that is using it sort of interactively, but we're going to talk about using it as an API. So let us move back into the slides, and we're going to talk a little bit about what it means to do, to build an AI application, a Gen AI application in general, right? So if you want an LLM to be more accurate, be more responsive to you, provide you better information, there's a handful of ways to make that happen, right? The most basic is prompt engineering or context engineering, where you say, you are a system designer and you have an emphasis on mobile design, and you tell the LLM, this is the persona you're taking on, and you give that as much information as you can in that prompt, right? So that's one way to do it. Another way to do it, and we'll talk about this a little bit more later, is tool calling, where you give the LLM access to additional tooling that it doesn't have currently. Right. So LLMs they are trained at a point in time. And so they don't really know what's going on right now by default. But if you give them access to search the web, they can search the web and find out. Right. So that's tool calling. They call a web search. The other one is fine-tuning the model. So fine-tuning a model is grabbing a model, adding your own bit of data to it, right? So I was working on this pirate chatbot, and I went and took a bunch of pirate open source stuff like, Treasure Island, and I fed it into the model to fine-tune it to be a pirate. And then the last is retrieval augmented generation. And that's the process of adding in your own data to the prompt, right? It's this idea of that the LLM knows how to like dissect data, and it knows how to like reason, and it knows how to do some of these things. But what it doesn't know is my world. It doesn't know my support tickets. It doesn't know my business metrics. It doesn't know anything that isn't publicly available. So how do I give it that information if I don't want to fine tune, for instance? So a chat completion LLM or chat completion app is kind of all the same, basically, right? We're going to write some sort of front end, and the user is going to ask a question, and that's going to be sent to some API, right? Which is exactly what we have today. We have an API sitting there. The API grabs that, right? And our API, I think in this one is in Python, and it makes a call to the LLM based to the LLM based on the URL I give it. And so like in this application, I could change that URL from Docker Model Runner to OpenAI and give it an OpenAI key, and it would use the OpenAI LLM, right? So, and then in Docker Model Runner says, oh, you want to use Llama 3.2? Let me give you that LLM. So it loads it up into memory for you. You don't have to preload it. You do have to pre-pull it, although I think they're working where you won't have to. So you want to access that model, there it is. The model gives us an answer. We send it back to the API, it forwards it back to the client, and you see the answer. Again, this is really just, basic information. This is the stuff, whatever the LLM is trained on, doesn't include any specific information. So how do we get a model to know our stuff, right? How do you know stuff? Like, what is this idea of meaning and context and similar? So we're gonna dive down a little bit into the theoretical layers about this. So if you think about it, and I say to you, I'm gonna go buy an apple, what do you think of? Right? Well, I think it depends on the context of the conversation, right? If I say I'm gonna go buy an apple, and you just said, what are you having for lunch? Boom. I'm going to go buy an apple. If you said, oh, I'm thinking about getting a computer, and I said, oh, I'm going to go buy an apple. Well, there we go. I'm going to go buy an Apple computer. But the meaning of that shifts. So how do we get that stuff how do we get that type of information into our system, right? And it's the same sort of thing, if I was to say to you right now, my car won't start. Just think to yourself, what would your question for me be? What would you go to for troubleshooting? My car won't start, right? Well, I'll tell you how I think I would process it. I would first say, well, is my battery dead? Right? Because that's the most common thing that's ever happened to me. Like I've killed the battery, I've left the lights on or something, right? And then maybe if that wasn't it, maybe I ran out of gas. Right? Because that's happened a couple of times, and I know that can cause my engine not to run. And then maybe I'll be like, well, my engine was making a funny sound. The belts were squeaking. Maybe they broke. That's a pretty extreme circumstance. One thing I would probably not think about is my brakes squeak, right? So the idea of my car won't start and these 4 answers, right? How do we know which of those answers is best for that question? Or for that sentiment? That is where we have to get into something called vectors and vector embedding and vector databases. So with retrieval augmented data generation, we're going to say, as I mentioned, hey, give me a response, but you need to put my data in the mix. So we have in Docker, we have an AI agent called Gordon, which we'll spend a little bit more time on, but he's right here. And this was a demo I was doing. He's got a tool to call GitHub, so he knows about my GitHub, but he also knows a lot about Docker. He has been trained on all of our documentation. He's been trained on internal stuff. So he's really good at answering questions about Docker, right? So that is he's got a solid backing of a good LLM, but it's been augmented with our data. And so that when you, as a customer, come up and you ask, like, I'm using Golang for a multi-stage build, and I'm not sure what base image I should start from, I'll give you an answer on that, right? So how do I get my data in there? How do I get my data into a format that my LLM can work with, that could, that we can work with? And how do I know in that big mix of data what is most relevant to that discussion that we're having? So the first thing you have to do is you have to convert all your data into vectors. Vectors are why I have an information systems undergraduate degree and not a computer science undergraduate degree. I did not do very well on my linear algebra class, so I changed to information systems. So that is what you have to do, right? First, you have to get all that data into this vector format, and we're going to dive into that. And then you just do normal chatbot stuff, right? But you include your data. You literally append your data to the prompt, and I'll show you that in the app. So what is a vector? A vector is a collection of numbers that represent the meaning of some bit of text, not a word. It's not, here's the numbers that make the word cat. Here's the numbers that say this is a mammal, four-legged, fur, feline, right? All of those characteristics. The more dimensions you have in a vector, the better it can be. Now, vectors operate in n space, which means they can have any number of different dimensions. I'm just going to say, for the sake of us, we live in 3D space, right? So let's just think of vectors in 3D space. If you have more dimensions, you have more nuanced evaluation. The way you know something is, has close meaning or close context or close relation to something else in a vector, a database, is how close those two things are if you do the math. So if you look at that diagram and you say A is apple, B is banana, C is cat, the distance between A and B and A and C shows you how similar those things are. So because the distance is shorter from A and B than A to C, A to B is a much closer match than an apple to a cat, right? An apple to a banana, of course, is more similar than an apple to a cat. So what you're doing is you're converting all of your data into these numbers. That's a one-time operation. We'll look at that next. And then when you run your app, you have to do the same thing for the user's question. Then you take the user's question and you do the math against you actually do a search and you say, give me the 5 things that are most similar to this. Then you can do math on them to see what is the most similar. And then boom, you're done. And actually you don't do any of that math. It's all done for you by the libraries. So, all right. So this is what it basically looks like to chunk up your data. I apologize. I do not have this code in my repo. I didn't put it in for some reason. I just put in the finished product. But basically what you do is you take a bunch of data. In my case, it was JSON, support ticket data. And you feed that into an application that will take it and break it into bits, right? However many words or characters you need to get the meaning of that phrase. And then you send that into the embedding model. And then that gets stored in a vector store. So common vector stores, Pinecone, Weaviate, Chroma. I am using something called Facebook AI Similarity Search, which is, it just writes stuff to the disk and then it loads that up into memory when it starts. So it's real lightweight, great for demos. I don't know what else you'd build with it, but for understanding how this works, it works great. So now let's look at what our app does, right? Let's look at how this works. So what happens is I've got my front end out there. I've got what's called, it's Streamlit, which is a Python framework for building chatbots, basically. And I ask it a question, or I say the user cannot log in. So it takes that question and it converts that question into a vector. The embedding model that you use in your application has to be the same embedding model that you use to create your data store. This step, you only have to do this once, probably not ideal. What I would say is you need to do this as often as you need your data to be fresh, but this is a different thing than running your application. So if you were doing a support database, you may have a cron job that every 24 hours grabs the latest support tickets, chunks them up and puts them in the database, for instance. I just did it one time to set it up and there it is. So it goes out and gets this vector. Then it goes up to the vector store, in our case, Facebook AI Similarity Search file. And it says, show me the things that are most similar to this. When you ask that question, you tell it how many do you want? Give me the top K. I want 5. Give me 5. So it'll send you the five closest responses. Then what my application does, we'll show it in the code, is it looks at it and goes, well, all of these are really close, so let's use them. Or some of these aren't relevant, like they don't belong. The distance is too far, right? The distance between these vectors is too far. I'm not going to use them. So I'll show that in action. And then we take the prompt that we want that includes my system instructions. You are a helpful support agent. It includes the user's question, as well as any other history of the conversation between them. And then it adds in that extra data, right? So that literally becomes part of the prompt that gets sent to the LLM, right? So let's take a look at that. Oh, one more slide real fast. So these two outputs were both done on my MacBook with the exact same prompt, the exact same application, the exact same augmented data. I think the one on the left was DeepSeek, and I think the one on the right was Llama 3.2. And so the model you choose can have a profound effect on the responses you get back. As I mentioned, I was building this personal project. I built a whole test application that tested like 5 different local models against GPT-4 on time and quality of output to decide which one I was going to use. It turned out that GPT-4, so I had this weighted system scale 1 to 5. GPT-4 scored like a 4.4, and my local model scored a 4.1, but it was 3 times faster, and it was free. So that one for me. I didn't want to, I wasn't paying to get the extra 0.3. You might pay to get the extra 0.3, but for this little project, it doesn't make any sense. All right, so let's go ahead and look at the actual application code now, right? So I have told you all everything about it. And so the one thing I'm going to say is the only part of this application that is dependent on, that is even tied remotely to Docker is when we start it up and we tell it where to find the LLM, right? So when we go in and we start our application, so we go into main.py, we come in and we say, look, go ahead and tell me, I have an environment variable called LLM name, and I have an environment variable called LLM URL. So this LLM URL points to my local Docker model runner instance. So it points to HTTP localhost 12434 : engines llama CPP v1. That's the URL. If I wanted this to point to OpenAI, I would change that to OpenAI, right? So I can prototype or just run it on Docker, and it can easily transition, right? So we grab those LLL names and then we do 3 things for the embedding. 1, this is the same model I used to embed all of my data, right? So all of my data was embedded using this. I want 5 results, and they can't be any farther than 1.2 parsecs. I don't know what that represents, but 1.2, right? They got to be pretty close. So we are going to go ahead and fire this up. This is the API. The front end isn't really important. I'll show you what you need to know about the front end. But we go in and we load up our reg data. So this is the reg data right here. So if you wanted to customize this for your data, these are the lines you would change. You would go over and you would create your own Facebook AI similarity search file. Make this a little bigger for you. And I did that out of this JSON, right? So I have all these tickets in here. They're all AI generated, right? They're not real tickets, but I fed that into the embedding model, right? Which we said was MiniLM6 v2. And that is what we got with there. So we read the vector in, and then we also load up all of the JSON data to help us augment the responses. Then we get when we get the response back from the vector database, we use the JSON to map that to actual ticket IDs, basically. All right, so memory, LLMs don't remember anything. So if you want to have a conversation that retains context, you have to store all of the user's questions. So you can send them back and they get sent back to the LLM every time. The LLM is like my kid. It just forgets everything you ever told it. All right, so let's go down in here, right? So we're going to go in and we're going to say, hey, get the user's chat request, right? So the user is going to send in a chat request. And there's something in the app that says use RAG. So if we're using RAG, the first thing we do is we create the vector of the user message. This is the exact same command I used on every piece of JSON data in my FAIS application. Then we say, all right, I want you to search for query vec inside of index. Remember, index is where we read in the FAISS file, the vector file. And give me back those top 5 results, right? So you get back a distance and an index. And then we come back and we say, look, if the very first response you give me is farther than 1.2, you don't have any information that can help me. Don't bother sending anything to the LLM because there's nothing here to help me, right? So if it actually is helpful, then we go through and we get the ticket data based on what came back from the index, and we map those things in and we literally pin them to the end of the prompt. And here's the prompt itself. This is what gets sent to the LLM. You are a support assistant. You're answering questions for a support engineer who's acting on behalf of a customer. You have access to support tickets that may help with your question. You can use only the following support tickets if they show the issue was acknowledged but not resolved, blah, blah, blah. So what had we been talking about before? What was the question you just asked? And here are all the support tickets. If I was not using RAG, it would just be you're a helpful assistant and, do the best you can because you don't have any support ticket data. All right, so that's the application. That calls something called, that calls a function called query LLM using the prompt, the LLM name, and then LLM URL. LLM client is right here, and that's query LLM. And this basically just makes a call. It formats all of it, and it makes a call to the URL, right, with the right JSON. So it adds the headers it needs, it puts it in the right format, and it just gets a response back and sends it back to for the processing afterwards. So what does that look like when it runs? It looks like this. Blah, blah, blah. Okay, so here is my support chatbot, right? So if I said user cannot log in, it's going to go out and it's going to do the vector search, and then it's going to interact with the LLM to kind of make sense of that data. It's the LLM that's reading the stuff that came out of the vector database and saying, well, how does this relate to the question? What can I extract from that? And it says, the answer is this login issue has been acknowledged by our support team and a bug report has been submitted. We're currently investigating the problem and we'll provide further updates as soon as we have more information, right? And we apologize for the inconvenience. So there's the LLM being helpful, right? So if we look at the prompt that was sent, it's literally what we looked at. Here is the prompt, the system instruction. There is no conversation history yet. There was the question, and here's the relevant support tickets. So if I was to ask a follow-on question, does this affect any particular version? It didn't know, like that didn't make any sense, right? The same thing would happen if I went, does this, what is Bitcoin, right? What is Bitcoin? It responds so quickly because all it has to do to get to this point is look at the distance score between the vector and the question and say, there's nothing in here that I could do. I'm honestly really surprised it didn't find this because there is version information. So that's kind of weird. Now, if I turn off what is reg and I clear the memory and I say, what is Bitcoin? I just have a normal chatbot, right? And it's going to go up and it's going to tell me that it's a digital currency or whatever. And it's just going to answer that. So that's the difference between using rag and not using rag. Yeah, so that is the first demo. As I said, have the GitHub repo at the end for you. I also put it in the chat if you scroll back. So let's move on and talk about some other tooling. What are the scenarios when you choose Docker models versus OpenAI one? So that's a good question. And the reason I love Docker Model Runner so much is I can try a bunch of stuff locally and not be racking up charges on the API endpoints, right? Because you got to pay for those API endpoints. Um, I think that, depending on your hardware, you may be limited to models that only have, a fraction of the number of parameters that have been brought into something like a GPT-4 or GP5. Like really like you might be dealing with 8 billion versus 80 billion. So these models aren't going to be as smart. So if you need to do like really deep reasoning, you need to do really complicated multifunction stuff, you probably need a GPT, right? Or well, not GPT, but you need some sort of, big powerful LLM running on a big powerful cloud platform, whether that be OpenAI, or whether that be Bedrock or Vertex with Google Cloud, one of those. Because those machines are going to have bigger GPUs, they're going to have bigger models, they're going to process faster. So the smaller your model is, the faster it will typically respond, but it will also be less accurate. So the trade-off really is between how fast do I need it, how accurate do I need it to be, and how much am I willing to pay, right? If you aren't willing to pay, then you're going to use local models. In my scenario with my chatbot that I was building, for me, it was like, this is a thing for Halloween for kids to talk to a pirate. It's an animatronic that is wired up to Docker Model Runner, and it does speech to text, sends that text to the local LLM, converts that response into speech, and then answers the questions for the kid. Having it local was fine because it was faster and it was pretty good. So there we go. How does Docker Model Runner compare to Ollama? Very similarly, right? I think the difference is with Ollama, you're kind of like, you have this Ollama ecosystem, Ollama way of doing things. With Docker Model Runner, I didn't show this actually, I should have showed it. But with Docker Model Runner, you are living sort of in the Docker world, right? So you have Docker Model LS, right? To list models. You have Docker Model Pull. You have Docker Model this, Docker Model that. So functionally, they're pretty equivalent. It's just a question of, do you want to use are you more familiar with Docker commands? It's a great place to start. It's built into Docker Desktop. That's fabulous. A little bit of trivia. The guys who started Ollama, Michael and Jeffrey, they actually were the people who wrote, oh boy, this is even better because some of you are in Canada. They actually wrote the first version of Docker Desktop in a dorm room at Waterloo. And then Docker bought that, and then they were at Docker for a while, then they went off and formed Ollama. So we're good friends with them. We talk to them all the time. So yeah, I would never say anything bad about Ollama. Pick whatever tool makes the best sense for you. All right, so let's go into the slides, and we're going to just look at just a couple more things, right? Changing gears a little bit, right? So we talked about function calling. The ability for you to tell an LLM, that, it needs something else to do this question, right? So you build a tool and you build something that can get weather, you build something that can get time, you build something that can, whatever it is. And what you do is you tell the LLM when you send the message, right? So this is a parameter that we're going to send to the chat completion endpoint, right? This is Golang. We were looking at Python before. And it basically says, hey, you have these tools available to you. So if you can't answer this question, know that you have these tools. And it says things like, there's a description, right? So this tool is called Get Weather. This tool is used to get weather forecasts from the National Oceanic Atmospheric Association, right? This tool is a time tool. This tool will give you the time in local time zone. It expects the time zone to be provided. So you have these list of tools. And then what happens is you send this over to the LLM, and then the LLM will respond back. And it'll either respond back with an answer if it didn't need any tools, or it'll respond back and say, oh, by the way, I need you to call these tools for me. So why don't you go ahead and run Get Weather? And then after you run that, give me that information, and then I will answer your question for you, right? So if you said, what is the weather in Toronto today? It would need to go out and make a call to do that. All right, so you are ready to develop almost, right? So here's the issue. There is this thing, right? So I've been calling this tool calling, function calling. This is one of the problems. Everybody does this a different way, right? Previously, prior to MCP, which is what we're talking about next. And there was no standard way of sending these tools around. So if you were GitHub and you wanted to make an official GitHub, tool that your LLMs could call, how was I going to get that to people, right? And so how do we share them and reuse them? So that's where the model context protocol comes in. This is from Anthropic. And basically, rather than having a custom code out there that you write, you can go out to get there's hundreds of thousands of these things now, and you can find them and you can just run them on your local machine. So they run as a process. They're a server. They can run remotely as well. They can run locally over standard IO or HTTP, or they can run over HTTP for a remote host. And you basically go in and you say, hey, I got a question. And then it goes, well, let me check the MCP client to see if there's any tools that are relevant to this. It grabs that tool, executes it, and then it augments the question to get the right answer, right? So MCP standardized the way that tools get called. It gave us a way to send them to people, but it had some problems, right? One of them is that I don't know why. I guess I'm just supposed to talk about them here. I thought I had a slide in there that I put in. So what are the challenges with that? Well, one, this code is almost always designed to run natively on your system. MCP servers are written in Node and Python primarily, so you end up doing an NPX run or a UV run or something, right? So do you have the right dependencies? Do you need to set up a virtual environment? What do you have the right version of Node? How did we solve those problems before? Like, we all had those problems 10 years ago. Many of us don't have them anymore because we put all that stuff in containers, right? So that's what we're doing with the MCP catalog, right? The other thing is, how do you handle secrets? If I have to call an API from my tool, right? If I write a tool to get proprietary information from some sort of data provider via API, how do I secure that secret so that I can communicate with that, right? How do I provide that to the MCP in a way that I'm not going to be compromised? That's another challenge, right? So how do I share them? How do I set up the environments? All that. So that's where the Docker MCP catalog comes in. The MCP catalog basically presents to you, right now it's about 160 different MCP servers. People can contribute if they want. You can just put them in you do a pull request on our repo, and then we'll review them and build them, and there they go. They are containers that are these MCP servers. The other challenge with this is, if I need to run 5 MCP servers traditionally, the traditional manner, I have to start each one of them. Each one of them has their own connection endpoint, right? So you have all of this networking that needs to happen, all this cross communication. With MCP catalog, we have the ability to front them with something called the MCP gateway. And the MCP gateway, I'm trying to see if it's in here. It's not. Okay, the MCP gateway basically acts as one single point. So you run one container, the gateway container, Docker run MCP gateway, and it knows your configuration from Docker desktop, right? Or just Docker. And it says, oh, you want these 5 MCPs? Okay, they're available. And so when somebody needs to make an MCP call, they just say Docker run MCP gateway, right? And they run the gateway, and they can make the call over standard IO, and we'll sort out getting them to the right ones. Rather than go through these other slides, I'll just show you the MCP gateway stuff because it's just easier to show it. So in Docker Desktop, we have the MCP toolkit, right? We've got, it's up to 170 now, 171 different MCP servers. For me, I have picked 3 of them: Docker Hub, DuckDuckGo, and GitHub Official, right? And so for GitHub Official, if you go in here and you look under configuration, you can see that I provided a personal access token that is stored as a secret securely here in my Docker desktop environment. And it's provided via the MCP server as needed, but I'm not having to hard code it anywhere, provide it into some weird third-party code that I don't really know what's going on. And these are the tools available to me. So with this installed, I can use something like Visual Studio Code, which I've already got, right? So if I go up here and I go, actually, I always do this and I do it wrong. Command-Shift-P. I'm going to do list my MCP servers, right? So I have Docker MCP gateway, right? And it is stopped. So I'm going to go ahead and click on that. And let me show you the configuration first. The configuration is like I said. We said here is the MCP gateway. It communicates locally over standard IO, and it's Docker MCP gateway run. So now if Copilot needs a tool to do some work, it can check the MCP gateway to see if there's a tool that can help it. So let's go ahead and start this up. So it's running. You can see the output. Well, normally you can see this here. Normally when I start it up here, I don't start it from in here, but you can go in and you could go into Copilot, right? And let me go ahead and pull this out. I was doing this earlier, an earlier demo. So let me go ahead and what do I want to do? Which one of these is clear? Oh, I don't know how you clear the conversation, whatever. So I could say, do I have any private GitHub repos, right? And so what it's going to do is going to look at the tools. It's going to say, oh, I can get your identity using the get me tool, and I can use the repository tool in the MCP server to list your repositories, and I can find out if you have any public or private ones, right? And so you can do that here. So we'll let that run, and then you can also do that, for instance, with Gordon in Docker AI, right? So this is what this was. This was me going, and what I was talking about here was that models are going to have different biases, right? So in here, I said, do I have a repo called BLE? Now, I meant a GitHub repo, but the LLM, right, Gordon said, oh, I'm kind of Docker centric, so he must mean a Docker repository, right? So if I was to say, do I have any GitHub repos named BLE? Then rather than using the Docker Hub tool, it would use the GitHub tool, which is what it just did. Get me. So you notice the tool calls are different. For Docker Hub, it was get personal namespace, check repository. For GitHub, it was call, get me, and search repositories. And it gave me back a link. I can even have it be like, hey, create a public repo, WeCloudData. And it will go out and it will do it. It does all of that through the tools. It does all of that. If I don't want those tools available anymore, right, I can just go into the MCP toolkit and I can disable them and say, I don't want them anymore. You can one-click configuration for a bunch of different clients. And of course, you could write custom code to access them as well. So I think that is, that's covered all that. All right, so yes, that is the last demo. We have a few minutes left for questions. I see, how about specific ML models that aren't LLMs? We're focused on LLMs right now. So that's not, it's LLMs. And then are vectors limited to augmented props? Vectors are a huge mathematical concept. And I think I think in the context of what we were talking about, that's what they're for, right? They're for the similarity, but they're also deeply important to how LLMs are built and a lot of that underlying stuff. So, and I am not an expert on them. And so I would just say they are not limited to augmented prompts. They're foundational to machine learning in a lot of ways. And so, they have a wide application. Yeah, there was one in here about how can we make the LLM integrated into our application more opinionated so it doesn't change its mind when users provide new information. A lot of that comes down to the way you prompt the LLM and the LLM you choose. I will tell you that when I was building my first chatbot for this pirate thing, I keep talking about it because I've been working on it for months. I spent more time writing the prompt than I did writing the application code to get that 5 p.m. Pacific time. I spent more time writing the prompt to get the thing to behave the way I wanted it to than I did on the actual code to do the LLM queries. I think, and I'm sure that the WeCloudData folks have opinions on this as well, but prompt engineering is super, 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 super important. And it is, calling an LLM API is easy. Getting it to do exactly what you want is hard. Um,
Absolutely.
yeah.
Agreed with Mike there.
How can we learn more about building AI agents and MCP tools using Docker? The Docker blog, um, the Docker blog has a bunch of posts on it. We have in those blogs we have links to code samples. We do webinars. There's a lot of that. There's also if you just Google it in general, our Docker captains have written a ton on the subject. And we just released a new agent, yes, a new agent building framework yesterday called C Agent. So go check out that. That's at github.com/docker/C agent, I think. I'll just put C agent here. C with the letter C, Cagent, right? C agent. And that is a new framework for building agentic applications. We can come back and talk about agentic applications another time.
Absolutely. Would love to have you back, Mike.
Yeah.
Adam, I think we have 2 more minutes, so we might want to be selective about final questions or so. Otherwise, I'm sure folks can reach out to Mike and Docker as well. But a really great presentation, Mike. Thanks so much for stopping by. I know everyone else, just like myself, learned quite a lot. But more importantly, I think we're all excited to, after this session, also try our hands on Docker Desktop and Docker with a local AI development. Really informative and really appreciate your time, Mike.
Yep. Thanks, y'all. Have a great rest of your day.
All right. Thanks, everyone. Have a great rest of the evening. Take care.